Okay, let's say that you had the graph of a function that looked something like this. Where do we have discontinuities and what type are they? Well, at -4, so at x equals -4, we have a discontinuity because if this is a roller coaster, you die here because you're going to fall straight down. Now, what type of discontinuity is this? So I decided to name this function f of x. And at x equals -4, f of x has a removable discontinuity. I may have misspelled that. I'm not an English major, I'm a math major. Sometimes we call a removable discontinuity a hole. In calculus, we tend to call it a hole. The official name is a removable discontinuity. And it looks precisely like that. It looks like an empty hole that has been plugged in somewhere else along that vertical line. Now, the next one. What about at x equals 2 and at x equals 6? You see, because at 2, you skyrocket up and you shoot down. At 6, you go down and you go up. These types of discontinuities are... So we call them infinite discontinuities because they tend to stray off toward infinity. So these are these are infinite discontinuities, pardon me, and they tend to sort of have a vertical asymptote running through them. Now this last one here, so can you guess the name of this? At x equals 8, again, you always tell me where, at what x location this glitch happens. At these particular x locations, something bad happens. We have a removable discontinuity. We have a couple of infinite discontinuities. And at 8, we have what we call a... So they tend to call it a jump discontinuity. Is that the official name? I actually don't know, but I think it is. So we have a removable discontinuity, it looks like a hole, the infinite discontinuities, and what we call a jump discontinuity.